Keep it steady. Keep it steady.
And 44.
One reason we chose spaghetti, other than the fact that it's cheap and of course easily available, is it's a very unforgiving material. It's very brittle, which means is that if you look at it the wrong way, it breaks. Wooden structures that are, often done in competitions in high schools, that's easy to work with. If you can build a structure that holds a heavy load, that doesn't surprise anybody. If you build a spaghetti bridge, which is known to be, not a building material, yet you're going to make a building material out of it, and it holds these really fantastic loads, that's what gives you the wow factor. And what it tells students is that if you understand the material, and you understand the design process, and you construct things carefully, you can take what would seem to be improbable materials to do improbable things. That's what engineering is. The original class on which this was based is a 3-credit college freshman class that is taken in the course of a semester. But in the summertime, we condense this thing into 4 weeks. So what that means is that every day you are being hit with something new, and just as you're beginning to absorb that, we hit you with something new again.
I don't really know exactly what engineering is because there's a whole lot of different types of engineering, but I feel as though I'm experiencing more so what they deal with as far as problem solving and techniques in math and science, like how math and science is related to the real world. I haven't seen that before I got to this program.
When we're about to test, you put the bolt in, you screw the bolt in.
All the ones in blue are in tension.
Lego line.
Yeah, like if you made 2 of them.
That's why I love this course, because it's all about labs. It's all hands-on work. And like basically none of this stuff is like classroom. And you're always in it, you're always building something, you're always making something better, you're always changing the scope and the scale of the problem. It's amazing.
1, 2, 3, 4, 5. The ribbon cable's not attached. The ribbon cable ends right there.
I mixed up circuit 4 and circuit 5 on the ribbon, which caused the wrong sensors to activate. 13.
You're done.
Okay.
Let's take a test drive.
Went to Driver Hall. We need to know the actual distance a bird would fly all the way over to Gilman Hall. Which is up there. We had to do it with only 2 meter sticks and a little bit of string and some masking tape.
Once we know the height of both buildings, we can set up a rectangle and a triangle on top. We can use trigonometry to figure it out.
Well, how'd you know if your angle is right? You sort of
exactly. That's the point of this lab. We're learning about error and how it works, and it's fun.
It's an improvised surveying device.
I think I could say.
Never had to do anything like this before. Completely engineering innovation.
Right.
It's best.
Do you like it?
Yeah.
How much land is devoted to growing Christmas trees in the United States?
I did 300 million, the number of people in America.
Approximately how many people celebrate Christmas?
I think I multiplied it by 10.
And then how many real trees as opposed to people who use like fake Christmas trees?
And I got about 5 billion.
550 million.
You think you got the answer?
Yeah.
What makes you so sure?
You didn't tell me I was wrong.
There's no right answer. Some kids really struggle with it, and some kids enjoy the creativity and the freedom that they have to, take they just follow their mind, and the solutions that they come up with are incredible.
Really concerned about these middle straps.
The problem is, look at this connection.
Spaghetti is surprisingly strong. Usually the complicated bridges are more harder to build.
We changed the sign 3 times in 2 days. We're gonna use this, but that didn't work out.
We took spaghetti at 3 different diameters, the thick kind, the thin kind, and the angel hair, and we tested their strengths against buckling, put it on beams, and we placed the weight in the middle, and we measured how much weight it would take for the spaghetti to snap, and the spaghetti is stronger than a lot of people think. And now we're graphing them on Excel to see what those maximum strengths are so that when we build our spaghetti bridges, we have the strongest spaghetti in the strongest places, pretty much.
We started by pulling a piece of spaghetti to see when it would break, and now they have structures. They understand tension and compression. They understand, they're making predictions where their bridge is going to break. It's incredible. They've even done the calculations to come up with some of these designs. I'm proud of them.
I think what makes the program so appealing is that this provides them with a sense of independence and creativity that they've never experienced before. They're working in teams or on their own, and they're working in ways that's not just memorizing and regurgitating, but actually creating new things.
I'm not sure if these kids really understand when we see them do that type of thing, that we're looking at the people that are going to make cars that don't use gas or houses that are heated by the sun, and that if the kids in those t-shirts don't do it, then we have no idea who's going to do it for us in the next 10 years. And it just inspires you to see that they're going to do great things. So I was quite taken away. Very proud of my son. Very proud of all of them. They did an excellent job.
I think it's a great program. Like, it really teaches you to think for yourself and to come up with more than one solution to a problem. It's only leaning a little bit this way. And the people you meet and work with they're so great. They're so much fun. Although there's a lot of it's kind of communal suffering, so that makes it better.
I'm a chemical and biomedical engineer, and I was really, really impressed by the work, the level of the work. As a matter of fact, I wish I would have had such a course before I went into engineering, because a lot of kids understand very little about what actual engineering is. They hear it and they think they want to do it, but really none of them have a good grasp for it. And this is a great sneak preview.
5.
It helps you learn just useful things in life, like how you're supposed to, if you don't know something, how you're supposed to research and put all these different ideas together and make up your own opinion or way to get an answer. So it was cool.